We have a big show for you tonight.
You know, you really don't need to know too much more to solve equations that are very useful containing percents.
Prepare to be astonished.
When I work with percent equations, I say there are three groups of interpretations, if you would. And these three will take you a long way. Anything that contains the word what or how much or any kind of a question like that, we're going to interpret to a variable. Y or A. Most people like to use X. So any kind of a question like that, we'll replace it from English to math language, if you would, with X. Any verb or action word like was or is or would be is going to interpret to your old buddy the equal sign. He's the only thing that actually is or states an is, if you would. That's 2 out of the 3. And finally, you already know this. The word of or on is always replaced in math with multiplication.
Allow me to demonstrate.
Let's try one. What is 6% of $45.50? Well, let's go let's go one word at a time. You'll get to know this. What interprets to X? I told you, any question word interprets to X. Is becomes, we just said, equals. Now 6% is already in math language, so we just write it's already a number. Write 6%. Of is times, and there again, 4550 is already as a number. So you've got your equation. It's pretty easy. We just went word for word. Now, how do we solve this equation? X is already by itself, so all we'll have to do is multiply. It's going to be critical to be able to change that 6% to a decimal so that we can multiply. We know that that becomes 6/100ths. Multiply that times 4550, and you've got your answer. Does that seem reasonable? 6% of 4550? It does.
Hey, this is great, man.
So all you need to do is those 3 categories of information.
Yoink.
You say you've forgotten how to multiply decimals? Okay, let's review. We're going to multiply the numbers as though they were whole numbers. In other words, as though there were no decimal there at all. 14 times 23. Remember how to do that? Let's see. 4 times 3 is 12. Put the 2, carry the 1. Then 4 times 2 is 8 plus 1. Okay, now I'm going to multiply the 1. 1 times 3. Note where I put the 3, because that's really not a 1, it's really a 10. 1 times 3 is 3. 1 times 2 is 2. Now I'll add up the partial products. And I'll get 2. 9 and 3 is 12. Carry the 1. And 1 and 2. Now what do I do with that 322? I'm not done just yet. I have to count the decimal places in the original question. I see there are 2 decimal places, so I'll take my 322 and move the decimal from the right, which is where it really is, over that many places, and that's my answer.
Genius. That's what it is.
Now, why would I need to know that?
Well, ooh-la-dee-da.
Well, here's a question that's going to involve multiplication of decimals, I bet you. What is 15% of 2550? Why would I want to know that? Well, typically we tip in a restaurant, you tip 15%. So you'll need to know how to figure out 15%. Well, what becomes X is always equals 15%. It's already in math language. You can put it in decimal if you want. We'll do that in a minute. And of, what are we supposed to change that to? Becomes times. Remember, you can write the times like that if you want. And 2550 is already in math language. It's already a number. So what we basically have to do, we have X alone. is multiply 15% as a decimal times 2550. And you should now know how to do that without a calculator. And we get 3.825. Well, what is that for money? What should you give the waiter if it comes out to that?
What a gem.
Yeah, I know it's a little bit more, but we'll give him a nice tip. Give him a little bit more. Okay?
Well, thank you very much.
Okay. Now we don't need to know any more
Now what am I gonna do?
if we have to work backwards. No more. Watch this. 312, suppose we wanted to know 312 is 75% of what number? Well, let's once again, to have the discipline, go one word at a time. 312, already in math language, is becomes equals 75%, already a number. Remember what of is, times, and what number becomes x. Okay? I'm going to treat what as what number. Now, I've got to solve for x. In this case, x is not alone. So, I'm going to first of all replace that 75% with the correct decimal. And then, what do I have to do to get rid of the 75 100ths? Well, he's multiplying x, so I'll divide
Wait
x.
a minute.
Got to do it to both. And what I'll end up with is x equals whatever 312 divided by 75 100ths is. Ends up being 416.
Excellent.
And that's the answer.
Remember.
Now, I know you're getting nervous because you're saying you forgot how to divide decimals. Okay, let's review that just a little bit. When we divide decimals, we've got the dividend and the divisor. The divisor is the guy you got to keep happy. He's the one that does the dividing. That's the 0.05 in this case. Okay, we're going to have to make him a whole number. In this case, to make him a whole number, I'm going to have to move the decimal place over 2 places. So if I do that to the divisor, I'm going to have to do the same thing to the dividend. Now, as soon as I move that, I think I'll forget, so I put the decimal place up near the answer, the quotient. And then I can just forget all the decimal places. Okay? Let's do the division now. 5 into 22 goes 4 times. 4 times 5 is 20. I'll subtract. Get a 2, bring down the next digit. 5 into 25 goes 5 times. I'll multiply. 5 times 5. Subtract. And I'd keep going if there was a next digit, but there isn't. So I'm done.
Oh, gnarly.
Let's try another one involving that.
How about a little fire, Scarecrow?
What if you were in a store and they were selling dresses for $125 that they said were 40% of the original price? Holy mackerel. Well, I can't imagine what the original price is. Let's figure it out. $125 is 40% of what number? Well, let's go one word at a time. 125, already in math language, is, what does that become? Equals 40%, already ready, of becomes times. And what or what number is x? So here, I hope you see, we're going to have to do some division. First of all, the 40% is going to become a decimal so that we can do that. And who's keeping the x from being alone? Well, there it is, that 40 100ths. He's multiplying,
Wait a minute.
so I'll divide. I'll do the opposite. That one will go away, and x will equal whatever 125 divided by 0.40 or 40 100ths is. That's why you need to know how to divide decimals. And in this case, x will equal $312. Now, does that seem like a reasonable answer? I believe it does. If it was smaller than 125, I know I'd be wrong. But here, 125 is a discount of a dress that cost $312. Better be a nice dress.
I'll take it.
What if you were the sales manager and you had a dress for $70 and you knew you could afford to mark it off $10.50? What percent is that? Well, let's work backwards here. What percent of $70 would be $10.50? Whatever question you come up with, the nice thing is, if we take it a word at a time, we can answer it. What always becomes X. Percent, think about it, percent is a math symbol. Bear with me on this one. Of is times, and 70, always in math language already. Would be, now this is a new one. It's a verb type thing. Would be, believe it or not, it's going to be equals. And 1050 is already in math language. So here we go. X percent times 70 equals 1050. We're going to have to get that X by itself. First of all, who's keeping it from being by itself? I'm going to get rid of the 70 by dividing both sides by 70. Now, I haven't gotten rid of the percent yet. Don't just blow that off. On the left side, I'll have X percent. On the right side, I'll have the answer to 1050 divided by 70. And that'll be 0.15. Well, now, if you stand back and relax your brain for a second, what percent is 15/100ths?
Wait a minute.
What does percent mean? Percent means out of 100. So it's like saying who's buried in Grant's tomb. What number out of 100 is 15 out of 100? The answer is 15. 15%.
I make this look good.
Not so bad, is it? Remember writing a fraction as a decimal? It's worthy of review. What we're basically going to do is divide the top by the bottom, or divide the numerator by the denominator in fancy language.
Well, ooh-la-dee-da.
That's all there is to
I
it.
have a feeling some bad stuff is about to go down.
Well, let's see how we're going to use it.
Now look at, I say look at here.
Let's change, for instance, 2/5 to a decimal. Why would we do that? To make it easier to compute with. It's going to be top divided by bottom, 2 divided by 5. Now the problem in this case is that we don't have enough digits. So we add some zeros, put the decimal after the 2. Now 5 into 20, well, into 2 goes nonce. So then I try 5 into 20, and I put the answer in the appropriate place, and I get 4, multiply, subtract, and I could bring down the next digit, but I'm really done, aren't I? Here's one that involves changing a fraction to a decimal, or to a percent anyway. What percent of 80 would be 68, or would 68 be? Once again, let's take it one word at a time. What, that's X, percent, well, just write it. It's already in math language. Of, or on, always becomes times. 80's all ready to go. Now would be, or could be, or is, it's going to be equals. And then 68 is ready to go. So we've got to get X alone. Once again, who's keeping it from being alone? The 80. Since he's multiplying, I'll divide. And X percent is going to be this fraction, 68 over 80. Now 68 over 80, once again, we're just going to change it to a decimal, dividing top by bottom, and you'll get 0.85.
Wait a minute.
Well, read to the hundredths, we shouldn't say 0.85, we should say 85/100ths. And what percent is 85/100ths? 85%. Well, you're going to have to practice this. So get to that homework.